Okay, so today I will kind of talk a little bit about how you can make your Python environments more easy to maintain, but also how to make them reproducible. And there are several ways in Python to do this. I will go through them in a kind of base way, that is the built-in Python way, but also I will go through how it's done in Anaconda, because they use a different, similar approach, but it's a tool that comes with Anaconda. So I'm not sure if you have already started to use environments, but when you start Anaconda, you are in something called, it says base on the left side. This is the base Anaconda environment. So and that contains all the packages that are part of Anaconda distribution default installation. If we install packages here with conda install, they will install in this base environment. Sometimes when you do that, you, especially if you have worked for several months, something you add more packages to this environment, it can get quite overcrowded with packages. So some packages will conflict with other packages, and you get into some, what I call the package hell of Python, because at some points you just, okay, now I have to reinstall entire Anaconda installation, which is not, then you have to install all your packages again. But there is a better way of doing this, and it's called using, it's something called environments. And environments is like a small Python installation. So you can ask the Python to create a copy of its own environment, but basically without any packages. So in base Python, there is a command called Python vn, which you can create environments. So you do that by typing Python. Let's make it a bit bigger here. And then you type vn, and then you give a name of your new environment. So I do my env here. Press enter. So now it thinks a little bit. And at some point here, it will give me something back. So what it does now, it creates a directory. It will copy the files that are required to create a minimal Python environment. At some point, yes. So if we do dir now, you can see here that there is a my end directory. So if we go into that environment, you can see here that it has created an include directory, a lib directory, and a scripts directory. If you go into scripts, you can see here that there is a Python interpreter. There are some pip tool here for installing packages, and there is activate command here. So this is basically a small mini Python. So if we go back here again, look here, if you do pip now in the base environment, pip is a package tool. So if you do pip, it can install packages from a PyPI repository. And you can list what packages are installed by doing pip list. I have some packages now that I've installed for this lecture here. So, but basically it's a one-page list of packages. So if I want to go into my newly created environment, I can do my env / scripts. So this is I'm running on a Windows machine, so / here. If you're on a Unix machine, you do /. So it's similar. And then I do activate like this. Now you can see that it creates my env base. So this one is Anaconda environment. So if this is Python, it doesn't know about Anaconda, so it adds this to that. And now that Python environment is activated, and if we do pip list now again, we only have 2 packages. So now we have a blank, clean slate where we can install packages. If you want to deactivate, you do the same thing, but you do deactivate. And now you're back to the base environment again, and you do pip list here, and it lists all my packages again in my main base environment. So pip activate like that. So the main Python package repository is the pip package repository. Conda has its own, which I come back to later. So pip is the default for all Python, not only scientific Python, but all Python. So if we open here again, and we do pip.org. So this is the main Python repository. So here are all the packages that are available to you from the pip command. So for example, I maintain a package called Calthem for Python. You can search it here. I get all the packages that have been released. Click on that one, you can see here that project description, homepage, and so on. Then I can install this in my environment. So I do pip install Calthem Python. So now it downloads all the dependencies. Because the environment is empty, it needs to download several packages in this environment. So it doesn't reuse anything. This is exactly what is required for Calthem for Python. Nothing more, nothing less. But if you install this in base, it will look at, okay, this is already there. I will use that version. In this case, you get a clean install with just the things you need for running Python or the Calthem Python package. And you can see here that these are all the packages that's installed. Those are required not by Python, but so Python requires, for example, NumPy, and NumPy requires other packages. So you get a list of complete packages that the Calthem Python will require. It can take some time, so we'll give it. So in the next step, we are going to look at, so if we have an environment installed, you can ask pip to give you a description of all the installed packages in a way that you can send to your colleague, for example. Here are the requirements for my work or my program, and your colleague can take that file and reproduce that environment exactly down to the version number. So this is actually an important tool to create reproducible scientific workflows. I have no idea how long this will take, but hopefully not too long. Okay, I will do like this. I will create a new. We create a new environment here, which I just install a single thing in my end2. It will copy a lot of files. That's why it takes some time, because it's on a Unix or Linux machine. It usually creates symbolic links that make it much faster to do this. So let's activate. Then I do pip install because when you have downloaded a package, you can see here that it actually downloads and caches them on your local machine. So if the package is available, it will not be downloaded from the internet, but from your local cache. Like that. So if I do pip list now, you can see I have NumPy, and if I run Python here, I can load NumPy as well. So suppose now I want to freeze this environment and create a list of versions that I want my colleague to install. I can use a command called pip freeze. If I just run pip freeze like this, without any command line options, it will just list the packages that this environment will use, and it will not give you versions of pip or setup tools or something, because those are part of the Python distribution, but only the packages you have added to this environment. So what you usually do is pip freeze output to requirements. See, so this will create a file, requirements.txt, and if I type this, you can see here it contains just this NumPy equals to 123.4. And if you have many dependencies, it will list all the dependencies of that. So what you can do then you can give this file to a colleague. I will deactivate this one here. Then I will do Python -m -3. So I create a new environment, the 3. And then I will try to recreate this from the requirements file. And now you can see here that I have activities. If I do pip list, it only lists 2 packages. So then I can do pip. There's so many commands I need to remember here. So pip install -r, that means requirements. Then I can give you this file is outside in my and okay, I have my requirements here, so I can do it directly. Pip install -r requirements like this. So now pip will look at that file and install exactly those packages that I have in this file. So this is a very good idea if you want to make sure that you have the exact same runtime environment for something you're running. You can just also, here is my packages, install that, and it will work. So the pip list here, and you can see it's identical to the other environment. There is also another tool that you can use that is called pipenv, which is a package that you can install in your base installation here. So I will just deactivate this one here. So here I install pipenv. Should be installed already, so I don't have to do anything. And the advantage with pipenv is that it's a single tool to manage packages and virtual environments. It also is a bit better than venv to handle requirements, and it also makes sure that all the packages are installed and verified for their signature. So you don't get any you can verify that all the packages are identical to ones that you installed, including the binary bit pattern on the disk. So you can actually validate it not only with version numbers. And you can also make sure that you use the latest packages. So setting up a pip environment, you do here. You create, for example, I create a directory here for Carlsson lecture, like this. I go into that directory, and I say to Python here, create. I want to create a new pip install that will create a virtual environment for this directory. So now it created both a environment and also installed everything you required here. So you can activate this environment here by doing pip and shell. That will activate this environment. And you see here, I mean, this one here. It will also create a pip file for you and maintain that as well. And that contains a description of all your. So here you can see here I have NumPy, the packages here. It requires a certain Python here. I didn't specify a version here, so it took something from my installation. This is the Python version it requires. And here you can also exit from this one here. You can do pip and I will not do conf pip and. So now it looks for the Carlsson Python is a smaller version of Carlsson, which it installs in this environment. I think I'm doing it wrong now. I need to go into. Oh, sorry. You have to make sure they're in that directory with the pip file. I thought I was outside that, but now it will install this here. So these two tools that I showed you can be used in any version of Python. It doesn't matter if it's Anaconda or outside. This will work with standard Python. Anaconda, the Conda installation environments will only work with Anaconda. So shortly, so here also show that you can run this one. Yes. So what I've also done here in your documentation now, the compute in this course material here, there is documentation here on how to use virtual environments. There is also on how to use pipenv and how to use conda environment. So I have added this to the course material. So now I created this environment. So if I look in the pip file here now, you can see here I have NumPy and I call from Python small. And then you can do pip and shell. Now I'm in the Colfem lecture environment, and if I do Python here, you can do import Colfem core CFC. And then if you do help, you can see here that now I have the Colfem packages are loaded and available in this module here. And if I exit here, Python here, if I do import Colfem with core CFC, it's not available. So in this way, you can isolate and create isolated environment for your Python code. You can also, there is a command called pip and run that can run Python code in that environment that you have created as well. It's also possible to do pip and graph. This displays all the packages that your environment requires. So you have here Colfem Python small. It depends on all these packages here. So matplotlib, gmesh, numpy, and so on. And you have numpy here. I installed that before, so it's here. SciPy, tabulate, visvis. So you can see exactly how this environment, what packages are installed. You can also check for outdated packages. So you can do pipenv update outdated. Now I don't think it will find so many because I think it will install the latest versions of things. So as I install it now, but in a couple of months, when you do the same command, it will update those that are out of date automatically. But sometimes you want to stay on a certain version. This will not. It will keep all the versions that are installed in this environment. So that was using normal Python. So if you are using Anaconda, you can create a new environment using the create command. So conda create. Create minus n, and then you can say, okay, Colfem test. Hopefully that will create a new environment, completely empty environments, I would say. Okay, so I will not do that. I will do Colfem test 2. And you can see here also it will locate, the environment is located here. So Anaconda Miniconda stores their environment at a certain location on your directory. So proceed, yes. And now you can see here that you have, it says that you can activate this environment using conda activate Colfem test 2, and you can deactivate using conda deactivate. So let's see what happens. Conda activate Colfem test 2. Yeah, I will have to type correctly as well. So now I am inside my Colfem test 2 environment. Let's see if I do Python -v. Oh, so it's really empty. There's not even a Python interpreter. So if you want to use this environment, we have to install conda install Python equals to 3.10 to be like this. You can also 3.9. What is this? Conda create. Then you can type Python equals 310 here as well. Let's see if it can handle this. So now it creates a new environment, and you can see here that it's missing certificates here. Proceed, yes. But this will create a Python environment with Python 3.10. And the latest version of that 3.10.6. So in this way, you can actually have, without any risk, install multiple versions of Python and try out different features of the language without disturbing your other packages. So let's see here, conda activate, like that. And now I have a Python -v here, 3.10.6. And here you can install other packages. So conda install, for example, NumPy. This. And now these packages will go into that environment. So they will not occupy your base environments. They will be kind of completely isolated. This. And you can also see that when you install NumPy on Anaconda, it will install a lot of other libraries like Interlope and PMKL, because the NumPy libraries in Anaconda are optimized for running on multiple cores. So usually the default Python NumPy will not use that, but if you use the Anaconda, it will be more efficient and fast. So, okay, now I have that. You can mix and match both pip and conda packages. So my recommendation is try installing the conda package first. If there is a conda package that's more compatible with the conda installation and conda environments, if the package is not available in Anaconda, you can do a pip install. So you can combine them both into a single repo here. So in this case, I can do, for example, pip install golf and Python. So I would do the small. The conda create command, you can also list after the Python equals the version number, you can add package names, and you can install standard packages directly after that command, and it will install NumPy, Matplotlib, and stuff like that automatically. So you don't have to do it one by one. So hopefully it will complete at some point here. As I showed in the next, it's also possible to clone environments that you have on disk. So you can, if you have an existing environment and you want to make a extra copy without modifying, you can do a clone. So in this case, I can do conda create -n colfem test3 clone colfem 4. So now I can create a new environment called colfem test4, and I clone that from colfem test3. You can see here that environments can be quite large. So in this installation, it installed 10,369 files. So every package that we install contains a lot of files. So if you have a lot of dependencies, they can be quite large. So if you are using, for example, high-performance computers or resources like LUNARC or NSD, when you are starting doing environments on those home directories, they can kind of grow quite large, and you can hit the quotas quite easily. So it could be a good idea to kind of check the dependencies and remove unnecessary environments when you don't use them. I will speed this up in the video later. So now if we do a conda list here, you can see what packages are installed. And then we can go conda deactivate. Then it should be give us the same list here. Yes. So if we want to, just like we did in with our pipenv or the version environment on the normal Python, we can create a list of versions here that you can use to recreate an environment. So we do conda activate test3. I don't think you have to activate here actually. If we do conda list colfem, you get something like this. So these are all the packages that colfem test3 uses, and you can see here it has direct references to the repositories where you can download all the packages for this environment. Usually what you do when you do like this, you do output to a spec file.txt. And then you can do conda create -n colfem test5 file spec file.txt. So this will read the packages from this file here and create a new environment test5. So let's see, Conda. I have all the packages again. Wrong exit command. So we go back to Python. So if you look at that spec file, it looks like this. So this is you can send this to your colleague, and that will recreate the entire environment which you have on your computer. Another thing is that if you're using notebooks and you want to use environments, you need to add something to the environment, because by default the notebook server doesn't recognize it will start up in the environment that you have, but you want to switch the environment. You need to, in your environment, so if I do conda activate you need to install a package called ipykernel. And that will provide some additional files that are required for it to be able to integrate with the notebook. Actually, a huge number of extra packages. Let's see if I'm inside the right one. Yes. Like that. And if I do conda deactivate here now, sure I have. I have a smaller Anaconda installer called Miniconda, which is more compact and doesn't have Jupyter by default. That's why I have to add this. It's a lot of waiting for things here. Okay, so now I should be able to do and now the CodeFem test 5 should be available to load within the notebook environment. So let's see here. I'm a bit unsure if there is CodeFem here. Import. I'll try notebook. Okay, I have to check this, but it should be possible to load it using from Jupyter and get your exact environment. I'm not sure why it doesn't work today, but it's probably my demo, the demo god somewhere. Okay, so that was my lecture for today.